Hello guys, welcome back to my channel. In today's class we are going to be going through IGCSE Acid, Base and Salts. Subtopic: the characteristic properties of acid and bases. Today your teacher is going to be JC as usual, cause I'm the only one running the channel. There's one editor behind me. Don't want to come inside the video. Let's see him another day. So in this chapter, the subtopic, there are, if I'm not wrong, let me check, there are 12 key points which Cambridge wants you to know. These 12 key points, let's start with the first one. The first one is gonna be how acid reacts with these compounds, metal, carbonates and base, and what is the product of all these. Okay, now let's go through this together. Let me open my checklist. Yeah. Okay, so let's go to the first one, acid plus a metal. We always should remember this. We'll give you hydrogen gas plus a salt. Your example is your magnesium ribbon plus hydrochloric acid in your practical session or your theoretical practical paper. What is always produced is your hydrogen, and with those hydrogen you do the hydrogen testing. And acid plus a base will always give you water plus and salt. And the next one is going to be acid plus a carbonate, which will always give you CO2 plus water plus and salt. These are the three equations of four acids. These three equations you need to remember for your acids. Are you clear? Acid plus a metal will give you hydrogen gas plus a salt. Acid plus a base will give you water and salt. Acid plus carbonate will give you CO2, H2O and a salt. Now let's go to the next one Cambridge wants you to know, which is the testing. How do acid react to the indicators? So the first one is your blue litmus indicator, your blue litmus paper. Obviously you know if it's blue it's gonna turn red. You don't need to remember this for base, because you know this only for acid. Vice versa, you can use acid plus a blue litmus paper will turn red. Then you know it's the total opposite for the base. The red litmus paper will turn blue. And for acid, the morphine will be colorless. It will be colorless. And acid plus methyl orange is red. Red. Your litmus paper and methyl orange are the same thing. Same thing. I want you all to score the best you can, okay? Now the next one. So base plus now we are going to base already, cause Cambridge obviously they will require you to know acid and bases, as the chapter is acid and bases. So for bases there are basically two equations. One is base plus acid. You know it's gonna be the same thing, but one difference: if it's a base plus acid reaction, if the base is a metal carbonate, then you will have H2O plus water plus the same equation as above, a salt. If it's a ammonia salt, you have ammonia gas, NH3 plus you'll have water and salt plus salt. These are your key equations. I want you to remember these five. Actually you can cancel out the acid plus base lah, cause it's the same thing as above. So you have only four equations to remember: these two, these three, and this acid plus ammonia, base plus ammonia salt. Now let's see how does the base react with the indicators. Base plus a red litmus paper obviously gives you what? Blue color. The red litmus paper turns blue, opposite of your acid, and thermophthalin will be blue. Okay, will be blue. Let me just erase it and write in blue, easier to remember lah. Blue. And your methyl orange will be yellow. Methyl orange is only orange when it's neutral. Now let's go to the next point. So according to the, let me check the checklist. This should be your third question. I actually skipped it so that I can explain you the equations first, because rest are usually statements. So the third one is state that bases are oxides or hydroxides of metal and alkalis are soluble bases. So here what we are trying to say is that alkali is just base. Alkali is all alkalis are bases, but not all bases are alkalis, because bases can also consist of oxides and hydroxides. Then the next one, okay, the aqueous solution of an acid contains H plus ions, and aqueous solution of an alkali contains OH minus ions. You can ask me, JC, why don't we just say aqueous solution of a base? We just covered that bases, not all bases are soluble, and all soluble bases are alkalis or alkalis, whatever you can pronounce it as. And we got to the important thing, guys. Let me open this. Your important thing, your pH reading. So this is something I took from my IGCSE book only. So here you can clearly see 7 pH is neutral. Anything below 7 is considered an acid. Anything above 7 is considered an alkali. So what are considered strong acid? Strong acid are something between the 1 and 2 ranging acids. And what are considered strong alkalis? 12, 13 and 14. Ask me, JC, why so much difference? Alkali has 3 for strong and acid has 2. Not sure, because that's what my teacher taught me when I was young. How do we know what is this pH based off? Is the concentration of hydrogen ions. The more the hydrogen ions, the more acidic it is, so thus lower pH. So neutral substance are 7 pH, as I mentioned. pH scale and pH is the concentration of hydrogen ions per dm cube of solution. Universal indicator solution is used to determine the pH of a substance by matching color change to the color chart. This is the color chart, and in your exam you will be given it for your pH scale. If they ever question you on pH, they will give it. So the next one, describe the neutralization reaction between an acid and a base. So let's see. Let me write a sample equation. MgO, magnesium oxide plus no, magnesium oxide, no lah, cannot create water one. MgOH, possible? Yeah, possible. MgOH, magnesium hydroxide plus HCl gives you H2O plus MgCl. So you might ask me, JC, why does it create water? See, when these two solutions react together, the hydrogen ion from the acid and the OH minus ion from the base come together, and the charge of hydrogen ion is H plus and OH minus is minus. Then you can cancel out the charges. Now they pair together. Now they are a happy family lah. Water. Very very happy family. And also acids are called as proton donors, as H plus is just a proton. And base are called usually proton acceptors, because they require this proton to start this happy family. Then let's see, the strong acid and weak acid is based on the ability or how much they dissociate the how much they dissociate when dissolved. Basically, if it's a strong acid, then it will dissociate fully in an aqueous solution, and weak acid will only partially dissociate in an aqueous solution. And hydrochloric acid is a strong acid, and ethanoic acid is a weak acid. Why ethanoic acid is a weak acid? We'll see it in the chapter of organic chemistry. It will not be tested according to me right now, but you just need to know it's a weak acid, and the equations are given in the checklist. I will be posting the checklist down below, and that's it for today. Today the class is over. Next chapter will be oxides, the subtopic. Then will be the preparation of salts. I will give a thank you to you all. Bye bye.